Hi again, and welcome to my Physics Online video lecture series. Today's video, we're going to be talking about velocity and speed. This is another video in our little short series about descriptions of an object's motion, about kinematics in other words. Previously, I've already made videos about position, displacement, and distance. And I also made one just simply giving an overview of kinematics. So today we're going to be looking a little bit at velocity and speed. First up, we have to give a simple definition of what each of these two terms is. And the definition, there's an equation form and there's also kind of a words form. So I'll put the words form first and then kind of explain what the equation is and how it works. All right, both these terms, velocity and speed, are basically rates. Velocity is the rate change of position, or in other words, it is velocity is the rate of displacement. Similarly, speed is the rate at which distance is being covered. So it's the rate change of distance traveled, or it's the rate at which distance is traversed. So now we ask, what does rate mean? What does this term rate mean? Because we will encounter this term rate or rate change quite a few times in physics. So this key term rate, or alternatively rate change, is a very important term to learn. We'll encounter it over and over again over the course of a physics semester or year. So in equation terms, in an algebra-based physics course, all that we can do is basically say that velocity, which we represent with a v with a little arrow over it, and then position, which we represent as an x or y with an arrow over it, and displacement, delta x or delta y. And then our average velocity, v average, would be equal to, or would be defined as really, rate change, which is usually a delta of the thing that we're saying it's a rate change of. So delta x, notice that that's the same thing as displacement over here, divided by delta time. So rate change is always basically this delta divided by delta t for the object. Okay, so, and then this little bar over the top of it, this symbol means, or bar symbol means average. Now, we talked in an earlier review video about what average means, and there are different types of average. So in math class, you usually learn about essentially like an ensemble average, where you add a bunch of things together and then divide by the number of things that you've added. So if you want to find the average of the first three numbers, whole numbers, you'd be adding 1 plus 2 plus 3, which is 6, and then you divide by 3 because there's 3 numbers being added, you get 2. Okay, the other option is the median average. So you just order the things from smallest to largest and pick the one in the middle. So again, you get a median average of 2 in this case. Okay, well those are kind of like ensemble averages. There's also another way to average things, which is to basically like weight it by how much time elapses, or weight it by how much of this thing there is versus how much of this other thing. So pressure, for example, is a type of average. It's the average force per unit area. Velocity is a type of average, or average velocity is a type of average. It's how much displacement has occurred per unit time. Another type of average that you might consider is what's called population density. Okay, so population density is giving you an average number of people per unit area, or per unit map size area. So in an urban area, your population density tends to be much higher than in a rural area. It's another way of saying the average number of people living in, let's say, a square mile is much higher in a city than it is in the countryside. So you're still averaging, but you're averaging per unit area here rather than adding up the number of people and dividing by some number. So this is the same basic idea. You're adding up the distances traveled, or the displacements, as the case may be. So for speed, you do the same thing, but it would be the total distance. So this would be like distance divided by time. And either way, you're basically getting an average here. If you wanted to get an instantaneous value, that means what is the value right now? Mathematically, what you do is you consider what is happening at a given time, and you basically just take the time increment that you're dividing by to be a very short amount of time. In algebraic terms, equation-wise, that's about all we can say. So instantaneous value means at an instant, and basically means delta t is very small. Can't do anything else than that algebraically with equations. Now there is another way of considering these things mathematically that you could do, which is to consider them via graphs. And I don't really want to spend too much time on this point. I really think that necessitates a different video. But let's say that I happen to have a graph that shows me, as a function of time, how far some object has traveled. So maybe like the distance versus time. And this always has to be increasing or at 0. It can't ever decrease. But maybe this distance versus time graph, whoops, that's a little bit of a decrease. Maybe this distance versus time graph is doing something like this. Okay, so you can get an average value for, let's say, this interval between here and here. Okay, and so the average value basically would be akin to drawing a straight line that runs from this point to this point. All right, so the slope of this line, slope of line from one point to another, is the average speed in this case. So this would be delta of whatever's on the y-axis, which is d, divided by delta t, and by definition that just is the average speed. Okay, now if I wanted to get the instantaneous value of the speed, let's say that I wanted to know what is the speed at this exact moment in time right here. So we could say speed at this instant. Note that this instant would have a value of like t instant or something like that. Maybe we'll call it like t inst, as opposed to t initial and maybe like t final. So this would be t final, this would be t initial, and this one right here, this would just be like d final minus d initial divided by t final minus t initial. Okay, now I want to get the speed at this instant in time. And the way that I basically can do that is I put in another line, but this other line needs to essentially run tangent to this little curve at this point in time. So I kind of expect the line to be, something like this. This is basically tangent at that given point in time. So if I wanted to find the speed at that point in time, I would find the slope of this tangent line. So tangent line, or tangent line's slope, is instantaneous speed at this time. And how would I go about putting an equation for that? Well, basically I would have to pick 2 points that are on this tangent line. And so maybe I happen to pick this point because I know it is on the tangent line. Maybe I have a graph paper and it just happens that like this time and distance are easy to locate, and maybe like this time and distance are easy to locate. So I'd basically just use the data points for these two. So let's say that this is like time 1, distance 1, and maybe this is time 2, comma, distance 2. Well, v at this time would be distance 2 minus distance 1 divided by time 2 minus time 1. Notice it's the same basic equation that I used down here, but the difference being that when I'm finding an average, I'm actually finding points that are on this black curve. When I'm finding an instantaneous, I may use, and frankly have to use, points that are not on the black curve. At least one of the 2 points can't be. Or at least one of the 2 points is probably not, and in some cases 2 of the 2. Could they be on it? Well, yeah, this line does cross the curve in 2 locations, but that's coincidental. But that's how you would go about finding an instantaneous value from a graph, and that gives us sort of like a definition for instantaneous value. In a calculus-based course, we would maybe be able to say a little bit more about what the instantaneous value is mathematically with an equation, but this is as far as we can go in an algebra-based course. And that's it. That's all I'm going to do with today's video. I will make a follow-up in which I look at actually using these equations to predict distance or predict speeds, stuff like that. Because it is possible to do all those things. If I have an equation of fit for my line, then I can get off of it, for example, a speed and an initial position. Or if it's a displacement versus time, then I can get off a velocity and an initial position. But that's it for today's video. I hope that you learned something from it, and thanks for watching.